Hello friends, welcome to my channel RG Innovations. Please subscribe to my channel and click on the bell button and select all to get all notification of my future video uploads. In today's video, we are going to learn about the NOT gate or inverter. We will see the schematic, we will see a demo of the NOT gate, and we will see the application of a NOT gate. So at first, let us know what is a NOT gate. The NOT gate is a single input, single output gate. This gate is also known as inverter because it performs the inversion of the applied binary signal. That is, it converts 0 into 1 or 1 into 0. In other words, the gate which has a high input signal only when their input signal is low, such type of gate is known as the NOT gate. The logic symbol for the gate is shown below here. This is a symbol of the NOT gate, where if the input is A and the output is C, then C equal to inversion of A. Let us have a look about what other names are binary 0 and binary 1s are called. So here we can see a binary 0. It is also said as off status or logic 0 or Boolean 0 or false or low. And the binary 1 is also called on status or logic 1 or Boolean 1 or true or high. So in our presentation, we can say any of this to binary 0 or any of this to binary 1. Now let us have a look at the truth table of the NOT gate. As we have already seen, this is the symbol of the NOT gate and output equal to inversion of input. So the truth table is likewise, if input is A, then output is not A. If input is 0, output is 1. If input is 1, then output is 0. Now let us have a look at the ICs. These two ICs are NOT gate ICs. Both of these has 6 NOT gate built in. One IC is 74HC04 or 74LS04 or 7404 IC, and another is CD4069 or 4069 IC. Both of these are having 14 pins and both of these pins are configured same. We will see the schematic of these ICs in the next slide. And in these ICs, we can see a notch here and here at the left side or at the top side of the IC. And we start counting the pins from here, the left side of the notch. Like this one is 1, 2, 3, 4, 5, 6, 7, and the other side 8, 9, 10, 11, 12, 13, 14. This is same for this IC also. So now let's move on to the schematic of the IC. This is the pin out diagram or the schematic of the IC. You can see pin number 1 is input, pin number 2 is output of a gate. Pin number 3 is input, pin number 4 is output, same is for pin number 5 input, pin number 6 output, pin number 9 input, pin number 8 output, pin number 11 input, pin number 10 output, pin number 13 input, pin number 12 output, pin number 14 is VCC or it's connect to the positive power supply, and pin number 7 is ground, it's connect to the negative power supply. Now let us have a look at the circuit diagram of how we can implement a NOT gate in a circuit. We will see with only one gate, we will not implement all the 6 gates. We will show for one gate only, and the other gates also performs the same way. So this is the circuit diagram. It is same for both the ICs, as both the ICs have the same pin configuration. We can see this is the power supply, positive supply that we have applied to pin number 14. This is the negative. We have applied this to pin number 7. Also the ground negative power supply goes to 2 LEDs. One is connected with a resistance via a switch that will give the input pulse, and the output from pin number 2 is going to another LED. Pin number 2 is also connected to negative via a pull down resistance 10K. If we do not put the pull down resistance, the output will fluctuate when no input is applied to pin number 1. So we have to ground it with a pull down resistance. This is the circuit. We will see the practical implementation of this. So now let's check out the prototype of the NOT gate implementation. I have built this on a breadboard. So at the left side, you can see this is the power supply unit. Whatever voltage above 7 volt given to this, it converts to 5 volt or 3.3 volt. Now for this prototype, we need 5 volt. So we have selected this to 5 volt in both the lines. And in the circuit, we have used a switch that is used to turn on or off the input, and this switch gives power supply to this LED to show the status, and here is the output LED that will show the output status. Both the LEDs are connected via a resistance to limit the current, and the circuit is already shown to you. So we will see the ICs that are used as gate. Here you can see we have two ICs. One is 74HC04 and one is CD4069. Here we have used two ICs as NOT gate. One is 74HC04, you can see this is printed, and one is CD4069, this one. Both the ICs have same configuration as you have seen in the diagram. So this notch you can see at the extreme left, here is a notch and here is a notch. So from the left side of the notch we start counting the pins, like this one is 1 2 3 4 5 6 7 8 9 10 11 12 13 14, and for this IC also 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So both the ICs have 14 pins and both the ICs have the same configuration. Now we will put these ICs on the breadboard one by one and check the output. So first we are putting the 74HC04 IC on the breadboard. This IC is connected. Now we are giving the power supply. The switch is in on position, so the on LED is glowing now, and since the input is on or high, the output you can see is low. Now if we turn off the switch, the input is low and the output is high. It works like this NOT gate, as we have seen in the truth table of the NOT gate. When the input is low, the output is high, and when the input is high, the output is low. So we have seen the implementation of the 74HC04 IC, a hex input NOT gate. Now we will see the application of CD4069. So we are removing this IC and we are putting this IC. This is CD4069. Once we have put, when the input is low, the output is high, the LED is glowing, and we are turning this on. When this input is high, this output is low. Again, if we put this to low, this will go high, and if this is high, this will go low. So you have seen the implementation of both the ICs 74HC04 and CD4069. These are the NOT gates, and NOT gates are usually implemented where two devices are installed, but we need to operate one at a time. Now let us see the application of these NOT gates. The concept of NOT gate is used in the air conditioning system in the ATM of banks. Since the ATM machine needs to be kept cool, there are two air conditioners used and they run alternately. So when this power input is high, this AC will be turned off and this AC will turn on. And when this power supply will be low, this AC will turn on and this AC will turn off. This is not exactly the circuit, but this is how it works. So in today's video, we have learned what a NOT gate is, how a NOT gate works, and the implementation of this. Today up to this, in our next upcoming video, we will see another gate. We will discuss about another gate. Till then, bye bye, take care, have a nice time.